In this tutorial, I'm going to talk about marginal utility and marginal rate of substitution using calculus, everybody's favorite topic. I'm going to talk about marginal utility and how utility is constant along the curve. Anywhere along this curve, utility is constant, which means the change in utility is zero. I'm also going to discuss marginal rate of substitution and how the marginal rate of substitution, or the slope of the tangent line, shows how consumers trade two goods. The slope of the tangent line is not constant along the indifference curve either. It changes, it varies. And I'll be using calculus.
Along the y-axis is good y with numbers. Along the x-axis is good x with numbers also.
And the brown curve here is the indifference curve. This point here, point A, and I'm going to draw another point, point B, and imagine a consumer moves from point A to point B. We can calculate their marginal rate of substitution, or MRS. This is equal to the change in y divided by the change in x. Again, the change in y divided by the change in x. The little triangle is the change in, and it's the Greek symbol for the word delta. So it's equal to the change in y divided by the change in x. I could use d, the change in, which also means the Greek symbol for delta. So this is equal to dy over dx, which is the first derivative of the indifference curve. And you'll see why that's important later on. The change in y is that distance there, and that's 60 minus 40 divided by the change in x, which is that distance there, which is 20 minus 30, which is equal to 20 divided by negative 10, which is equal to negative 2. Again, that change in y and change to x is moving from point A to point B. I'm going to add another point, and let's call this point C. I'm going to look at the change in y and the change in x. Change in y is that distance, and the change in x is that distance. So I'm moving from point B to point C, and I'm looking at the change in y divided by the change in x. So the change in y is 40 minus 20 divided by 30 minus 50. This equals to 20 divided by negative 20, or this equals to negative 1. The marginal rate of substitution from going to point A to point B is negative 2. Another way to think about this is when I move from point A to point B, I give up 2y to get 1x. The marginal rate of substitution from going to point B to point C is 1. In other words, I give up 1y to get 1x. This is called diminishing marginal rate of substitution. Let me clear off my graph and get rid of all those numbers. Clean everything off. There you go. And now for some calculus. When I move points A and B really close to each other, you'll see that the slope of the line, or the slope of the tangent line, is the marginal rate of substitution. This slope of the line is not constant and changes throughout. The slope of that tangent line is the first derivative of the indifference curve. Utility is constant along the indifference curve as well. That means utility does not change. So along any point along this curve, the change in utility is 0. I'm going to use some different Greek letters, all meaning delta. Again, the change is 0, change in utility is 0, and utility is constant. If I take a point along the indifference curve right there, that's y1 and x1, and that's utility x1, y1. The second point with y2 and x2, the utility at these 2 points are equal to each other. Now I'm going to subtract from the equation utility at point x2, y2 from both sides of the equation. This gives me the utility of the first point minus utility of the second point, which is equal to 0, which means that the change in utility is 0.
The change in utility due to change in x is, again, the little symbol there is a delta, means change in. This is the change in utility due to an increase or a change in the consumption of good x. The change in utility due to a change in y is the change in utility due to a change in good y. This should be evident as marginal utility of x and marginal utility of y. Often written in your textbooks as MUX and MUY. Keeping these two items in mind, we'll hold that right there. Don't forget about them. Now I'm going to do a partial derivative. The change in utility is the partial derivative of the function uxy with respect to the variable or good x. The change in utility with respect to changes in x, that's a symbol for partial derivative, plus the partial derivative of ux with respect to the variable y or good y, which is the change in utility due to a change in y dy. The change in utility is 0, so this is equal to 0. Notice this and this are the same, and the blue, or the product y, that's the same as well. Now I'm going to solve for this algebraically. So I'm going to substitute that in and bring that dx down, plus, now I'm going to substitute MUY, marginal utility of y, for that right there, dy, bring the dy down, and the equal, and also the 0, just like that. Now I'm going to get the marginal utilities on one side of the equation, and the dx dy on the other side of the equation, the other side of the equal sign. I subtract MUY dy from both sides of the equation. On the left side, I bring down the MUX dx. The MUY dy's cancel out. This equals negative MUY dy. Now I am going to multiply both sides of the equation by 1 over dx. The dx's cancel out. I'm left with MUX, or marginal utility of x, is equal to the negative of the marginal utility of y, good y, times dy divided by dx. Almost done, just a few more steps. Now I multiply both sides of the equation by 1 over the marginal utility of y. Now I'm left with the following. The ratio of the two marginal utilities is equal to the slope of the tangent line. It's pretty crazy. Which is also equal, if you remember, to the change in y over the change in x. It turns out that the marginal rate of substitution is equal to the ratios of the two marginal utilities. For some of you, this looks like mental masturbation. I'm going to follow up with a numerical example as well.